I'd like to use these 4 items here, but cannot because I don't have an element of B yet. I can use this for all if I have something from S, but I don't yet. So where am I going to start? I'll go look over here. It says for all X and B. So we should pick something, or rather have the reader pick something from B arbitrary. You could call it X, but you could call it another letter. So just to make a point, I'm going to say our first sentence in the proof would be let M belong to B. For now in the flowchart, I'm leaving off the word let. But when writing out sentences, the first thing would be let M belong to B. Then at this point, take a look at this text here. This is what we would need to prove, although replacing all of the X's with M. So for a moment, we'll write in that we want to show if M has a hedgehog, then M plays chess. So in order to prove this statement, to prove an if-then statement, we should assume that M has a hedgehog. And then somewhere down at the bottom, we should include that M plays chess. So we don't know this yet down here, but we eventually want to know that that's going to be true. Okay, then together with the 4th hypothesis, now technically all of the hypotheses are up here in their own boxes, but I'll just kind of bring them up as we need them. We get, take a look right here, since we have something in B, we can use this 4th hypothesis. We get this implication. We just need to replace the B's that appear here and there with what we have. We've called it M. So we have if M doesn't play chess, then M is not affable. Okay. Also, we have that M is in B. We could combine this with the information from hypothesis number 1. Right? So every element of B is an element of C, and we get that M is in C. We can use hypothesis 3 together with M is in C to get that M is in S. Now, take a look. Is there one of these hypotheses that we can use that we haven't? It's right here. So pause the video for a moment and write what should we get. Don't pause yet, I guess, but I'd like you to write in what should belong inside a box here based on H2 and M is in S. Okay, I hope you pause the video and tried it yourself. But what we should write is the text that's after the comma in order to use a for all. It's going to be all that text here. We do need to replace the X with an M though, because that's the thing that we have from S. So I'll write in here if M has a hedgehog, then M writes poetry. I'll just abbreviate it like this, M poetry. So I hope you have a thing that looks like this. There should be no for all in that particular box right here. And then, take a look. Now that we have M has a hedgehog together, we have if M has a hedgehog, then M writes poetry together with M has a hedgehog. These two things together give us M writes poetry. And then, now that we have M writes poetry, and M has a hedgehog, take a look back at this definition right there. We have a Canadian, that is an element of the set C. Yeah, we have that like way back here. So this definition can apply. We have that M writes poetry and M is a hedgehog. So that takes the place of the R's here. We end up with M is affable. Right? So the fact that M is a hedgehog together with M writes poetry, this leads to M is affable. So now, what do you think we can do, now that we know that M is affable? Well, we can combine this new fact here with back here we've got this implication, and by applying modest tolerance, we end up with M.